All right, here we go.
Everyone's muted.
Yes, it's the smart way to do it.
Yeah, keep it that way, Salvia. We don't want to hear you.
All right, I'll mute myself. Bye, Hunter.
Where's Wiki Huther?
What up, Brindley?
Gosh, I haven't seen Brindley. Hey, Marola.
What's up, Chris?
Yo, Salvia.
Marola's here.
Paladino, what's up?
Good, yeah.
Man,
Marola?
everyone's here.
Where's all your damn khakis, guys?
It's like Smash. Everybody's here.
Bro, I'm not putting on my khakis. You're out of your mind.
All right. So everyone seems to have gotten in. Let's get through. Looks like everyone is in.
Attendance. Here.
Yeah, I'm gonna start calling roll. No. All right. So let's see. Looks like everyone found this all right. I wasn't too worried about you guys as far as getting on here is concerned. Thanks for filling out the. Oh, that's rolling backwards. Thanks for filling out the form really quickly. It wasn't graded, obviously. Now, anybody who's having trouble or doesn't have a mic or a camera or anything like that, you can phone in and still watch the video at the same time. So there is those numbers that were sent at the bottom, those call-in numbers. So some people are doing that. So you should be good there. Looking to Blackboard, I'm going to be utilizing it more frequently, unfortunately. Basically, what we're going to be doing is going to keep with the quizzes. So every time you guys come online, there's going to be a quiz the first 10 minutes. All right. What else? Now, with test, which I'm sure you're all worried about, and the final, and then how the breakdown is going to be. So obviously, we don't have lab anymore, since none of you are at the ship or at a school right now. We are going to be getting rid of that 10% for the lab notebook, and 3 people are still waiting to get in. How are you guys getting unmuted? There we go. If anybody sees that there's people waiting, let me know and I'll admit them. So let's see. Since there's no lab, we're not going to be doing the 10% from that, but I'm not just going to add 10% to your like final and all of a sudden make that 40%. So as far as like what I'm seeing, it's going to be like either some sort of attendance, 10%er, or participation, like we're going to go back to high school kind of mentality. So we'll go from there with that. Now, what we're going to be doing for tests are going to be done basically via Zoom. I'm not going to be like prompting, like it's basically not going to be like one question where you're going to have to write out or anything like that. The way we're going to do it is you're going to have the Zoom open. We're going to have everyone unmuted so that way you can hear. And everything is going to be open book. All right. So you're going to be able to use the slides, any notes you have. Just, it comes down to the honor system of basically don't be using your older brother, yonks. And don't be, you just have to not be able to use YouTube, stuff like that. All right. Just keep to what you have with your notes, keep to what you have with your knowledge. But the aspect of it is true is with these open notes is a double-edged sword. You're going to be timed. It's still going to be, it's not going to be open for 2 hours where you can do 50 questions. It's going to be, you know it or you don't know it kind of mentality. And if you're confused, that's when you look it up in your notes. All right, that's the way you're going to have to go with doing open book tests. All right, so we have one more exam. It's going to be hydraulics and it's going to be electricity. And then we're going to have the final. And the final, what I'm thinking we're going to do, since there's 62 of you in this class, the larger class, going back and forth and doing a actual examination or some sort of a verbal examination, 5 minutes of basically tell me everything you know about a ball valve or a gate valve, or tell me how to start up an evap, just the basic thought process behind it, things like that. So I'm going back and forth on that. We still have time to do that. Now let's see. Anyone who has not done a video conference before at this measure? I don't think really anybody has. If you scroll down to the bottom part of your screen, you'll be able to see all of these different controls, basically. So there's the mute button, the unmute. There's also your video. And then I can access polls here. Now, the other thing is there's a chat. So if you guys have questions, you can pop it into the chat. I'll try and look at it. But there also is like a hand raising button that does that, or if you agree, stuff like that. If I'm not seeing you, which, because I have 3 pages full of faces looking back at me, just unmute yourself. The way you can do that temporarily is you just press and hold the space button, and that allows you to unmute temporarily for a while, and then you can start talking, and just try and get into a spot where I'm not talking at the same time. So that way, if you have a question and I don't want to continue through the entire piece, we can go with that. All right. Sweet. I'm loving the reaction back. All right. Anybody have any questions? Anybody not getting, as far as information or anything they're confused on, or what's what? Let's go open up to everybody. So unmuted basically everybody. So if you have a question, just go for it. If not, we'll go ahead.
It's deafening.
Silence is cool. So how is everybody as far as all participants are unmuted. So how is everybody with communication back from the school? As far as it just been teachers that have been communicating with you, or what's been happening as far as your end?
Mostly teachers, really.
Mostly teachers. Have you gotten anything as far as from the administration?
Every now and then,
Every now and then.
they'll send like a little update, but like it usually has no relevance to like what we're doing at home. So
I was told apparently that they want us to come back April 20th for finals, and then 2 weeks after May 1st, they want to ship out for cruise, something like that.
So,
But
I had a meeting with my advisor last night, and he was saying that we're going to be doing this all through finals week, doing this video chat or whatever. So
right.
he said we're just going to be doing this probably through finals week.
So the plan is right now, and it changes every day. That's what you guys kind of have to take this as far as, like, some of you are upperclassmen. A lot of you were basically keep it with the everyday mentality, kind of like when you were in Indoc. Whatever's the new thing that's happening that day, just go with it. Just keep rolling with it. Don't stress too much about what can happen 2 days from now, because it's going to change. So the plan is we're most likely, probably not 100%, because I talked to some international students as my advisees. They've been informed that they're not having to come back to campus. So As far as finals week goes, that's still going to be finals week. We are going to be doing, the option is for instructors to be able to have in-person finals, even though we don't see how that, as instructors, when we talk to each other, how that would even physically be possible, allowing people back on campus, especially with the fact that we are now on, as far as New York is concerned, shelter in place mandatory since last night at 8 o'clock. That being said, the 2 weeks after finals, usually we have finals week, and then we have pre-cruise, and then the ship leaves that next Sunday. That's usually the mentality that happens. As you know, the US government is saying, don't go out on ships, and that thing is a floating petri dish times 1,000. There's a lot of talk at a lot higher pay rate than I am going on about what's going to happen on cruise or what's going to happen with cruise. So just keep those 2 weeks after finals week. They may not be vacation, they may be vacation, but I wouldn't plan anything necessarily for that. They might have you come back onto campus and we'll bang out 540 lab there for 2 weeks straight, basically, and then do pre-cruise and go out and go on the ship. That might happen. None of that might happen. You might just have the longest summer out of all of the SUNY schools out there, considering we end early. And we start kind of late. So a lot of things could be happening. But I would just take it in stride for all of you guys out there. So we're in uncharted territories. And one person wants to be admitted. So anybody have any questions about that or what I just kind of discussed? Like I said, space bar, you can just start talking. No? Okay. So that answered the exam questions. Ask that. All right. So with how office hours are going to take place, everybody understands that the email that I sent out to you is basically that is your weekly Monday, Wednesday link for class, correct? Everyone kind of understand that? All right, cool. I'm going to have office hours kind of playing the same way. We are going to have one link. It's going to be my office hours that are going to be here. And basically, it's going to be just a virtual office. The link is going to be on. Come in, start saying hi, because I'm probably going to have it minimized, and I'm going to be doing other work while I'm having my office hours. So just pop in and start talking and asking me if I'm there. So I'll have open office hours. Those will be posted to Blackboard. You'll have an email that'll be sent out to the entire class that way. Look to both sides. Email and Blackboard is how we're going to be looking at everything. Let's see. All right. So does anybody been in contact with anyone who has not have any ability to get online, has not seen anything? Anybody friends with anybody that are noticing that they haven't been able to talk to them since then, or?
I think there are just some people that don't want to wake up in the morning, but other than that, I think everyone's doing all right with this.
All right, good. So again, I'm going to be recording these. It's recording right now. I'm going to make basically a YouTube channel for you guys. So that way the entire lesson is going to be up on YouTube. So that way, if your internet cuts out, it's not your fault kind of mentality. You should still be able to get the material. If it glitches out, you should still be able to get the material. If you need to even just re-listen because this is a hard format to learn engineering in, you should still be able to get the material. So that's going to be linked to you guys. So that way you guys have this ability to rewatch the lesson. I'm going to have more office hours because now I don't have to have commuting being part of it or anything like that. All right. Other than that, let's go through with a revamp of what we did last class. Okay. So some teachers are going to be using Zoom. Some teachers are not. Coast Guard classes are going to be, from what we all determined as instructors, we're going to be utilizing Zoom because we need to have class attendance. Since we are STCW, everything like that, we need to make sure that we have class attendance. We need to make sure that we have actual classes. So this is what's called a synchronous. And then there's some instructors you may have what's called doing asynchronous, which basically means they spent all last week recording all of their lessons for the entire rest of the semester. And then during their lectures are going to be open office hours. Basically, you come to the lecture, ask questions about the homework, and then they are going to be giving exams in there. Everything else is going to be, you're going to watch a video with them talking, almost kind of like Khan Academy. All right, let's see what we got. Oh, that's just a. All right, let's go into PowerPoint. All right. Everybody see PowerPoint up? Awesome. So let's go. Basically, I already wrote the quiz for steering gear. Like I said, I'm going to upload it to Blackboard. The way we're going to do it is first 10 minutes of class, log into Zoom like you guys did today, pull up Blackboard ready to go, and it's going to be 10 questions, a whole quiz on steering gear, and we're going to be basically, you know, just 10 quick questions for you guys. I was going to use it as attendance, but then there's this other idea that I had that someone else presented that we'll be able to actually give you guys attendance, that you guys don't have to do a quiz in order to have attendance. But hopefully this will help your grades. I'm going to leave it up on Blackboard so you have the questions, so that way if you want to study for it for the exam, you have that as well. All right. So same thing as what we discussed in class. If you guys have, what do you call it? You're going to have quizzes almost every single class. You're going to have exam 3, and then the final is going to be something different. All right. So let's go through with steering gear. So as we go through, we basically have our components. We still have our rudder. We still have, let me pull up. Switch some windows around. It'll be better. This will be better for you guys. All right. So obviously we have our rudder. We have our rudder stock, tiller, steering gear, pumps, 6-way valve, and rams. So we know that these rams, the difference between the rams and our 6-way valve is the 6-way valve is controlling which steering gear pump is online. All right, that's all it does. It's not actually controlling which way the rudder turns. It's not controlling which ram is getting the feed of the hydraulics from the steering gear. It's controlling which steering gear pump is online. The rams themselves, the rams control which way the rudder is going to be turning. Okay. Now, when we go and we're moving the rudder, we have what's called a Rapson slide. The Rapson slide is what's going to be controlling, and it's the tilting motion that's going to be either moving these rudders one way or the other. Let's see if I can. Oh, there's the chat. Okay, good. So these are the Rapson slide. All right. It is not the ram that's going to be controlling the tilt plate. This is the Rapson slide. It's going to be controlling which way the rudder is going to be moving, utilizing the rams. All right. So what we have is just to move the rams, we're going to be utilizing basically our hydraulic pumps. All right. So they're going to be crossing over, and they're either going to suck from one side and pump to the other, and then they're hydraulically locked. All right. The rams are going to be locked hydraulically because the tilt plate is going to be flat. All right. So it's going to be spinning, but still having zero pumping moving through it. All right. Same thing on a port discharge. It's going to go the opposite direction, and then the rams lock in the new position. All right. Remember.
That pointy thing there is the rudder, right?
Yeah, this is the rudder down.
Yeah, okay.
All right. Here's the big thing is what we have here. This is the tilt plate. All right. This is the cylinder right here. They have all the pistons that are right there. All right. So they're going to be moving up and down. So when this tilt plate here is flat, we're going to have no movement in the rudder itself. All right. And there's going to be no movement in or out of our pump while the tilt plate is flat. All right. As soon as you still have an angle of your tilt plate, you're going to have movement going in or out one way or the other. All right. Just like that. And now you're in the position you want to be in, and your tilt plate goes back to the zero position, and you have no movement on your rudder down here. This is staying stagnant. So just like we talked about, the 6-way valve right here is going to be only controlling the flow of hydraulic oil, basically from which steering gear pump, either port or starboard, is online. So right now, if we call this one, actually we call this one starboard. Which one is online right now in this condition?
Starboard.
Yeah, the starboard one is online because that's having the flow going through. All right. So, but we're having no movement because our common stroke, where basically our tilt plates are in a neutral position. But as soon as we have any sort of tilt, and just like we said last class, these are both controlled by the differential, by the yoke and the differential, which is therefore controlled by the ram. All right. Both of them are going to be moving together, even though hydraulic oil is only being sent from one side. So the starboard pump is the only one sending hydraulic oil to our rams. And we go in the opposite direction, and now we have flow going the opposite way, even though our steering gear pump is still spinning in only one direction. All right, now we go back to our neutral. And now we're going to have our 6-way valve spin. All right, and this allows us, again, to control which steering gear pump is online and which one is not. So we have our port pump, and we have our starboard. Our starboard pump is online right now. Same thing again. If the tilt plate is moving one direction or the other, you're going to have flow going from only the starboard pump to our rams, whereas our port pump is just basically circulating. Again, this is how the rams are going to be going in different directions. So it has 3 positions, okay? Always 3. One is for the starboard pump online, the port pump is on standby. Like we talked about in class, the port pump could be running, it could be not running in any one of those conditions. All we know right now is that it's on standby. It allows it to run, but we don't need it to be running. All right. Position number 2 is the port pump is running, the starboard pump is on standby. And position 3 is a locked rudder position. All right. Like we talked about, this might be when we are in dry dock and we're trying to remove a portion of the shaft or anything like that. We want to make sure the rudder is going to be locked hydraulically. Or we can be in a position where we're going to be dead sticking down the Hudson and we're going to be getting towed to the scrapyard because our ship is old and we don't want to have any ability for the ship to start steering itself. All right.
So why is it a 6-way valve if there's only 3 positions?
It's because of the, basically you have your 6 pieces coming off of it. So it's going 6 different directions flow. That's why. Not based on basically the 3 ways that it could be in a position. It's where all the hydraulic oil is going to be going. All right. So negative feedback loop. All right. This, as far as what we're concerned with here, is we're looking at something that is just like we talked about. If you need to have 10 apples for some recipe that you're going to be cooking that day, when you're in the store looking, you basically are going to be grabbing one at a time. And every single time you get one, your mind is going to be computing, okay, I grabbed 1, now I need 9. I grabbed another one, I need 8. And it's basically, that's the mentality. You're not always just sitting there when you're grabbing apples going, I need 10, I need 10, I need 10, I need 10. And all of a sudden you have 20 apples in your cart. The aspect is that you're going to be, every single time you grab one, you know you need 1 less than you did before. And that is your actual, what's going to be going in. Your feedback is how much you have. And this is what you want. All right, let's talk about the differential. Is everybody understanding? If you don't understand the negative feedback loop, let's talk about it before we get into the differential.
Yeah, now go back, please.
You need to go back?
Yeah, can we go back to the loop?
Yes. And by the way, guys, I'm still going to be posting these slides as well. I'm actually going to be posting. These are posted. I know I posted these. but I'm still going to be posting the slides, and I might even post them before class as well. So that way, if you don't have the greatest connection, you can listen to it on the phone if you need be. All right. All right.
Mr. Callahan,
What's going on?
you said you're gonna put these on YouTube, right?
Yes, I'll link which YouTube channel.
Okay.
How am I coming in as far as with everybody? Am I coming in clear? Am I coming in too quiet?
You guys sound good to me.
Yeah, completely good.
Okay, good.
All good.
Just so you guys know, I spent a lot of time getting this ready. I run Cat 6 cable through my house trying to basically get a good internet connection for you guys. All right, ready to continue on?
Yep, all set.
All right. So with the differential, we have our input gear. All right. We have input gear number 2. This input is coming from the RAM. All right. And the RAM is coming from the helm. We're input gear number 2. This is coming from the rudder itself.
You're muted.
Yeah, you're muted.
All right, thank you. I must have hit the mute button by accident. So as this rack turns, you're going to be having an input gear number 1 is what you want. That is your 10 apples that are going in. What you have is coming from the rudder. All right. This is your want, and this is your have. And this is your output. This piece right here of your yoke. This is what is in your cart. All right. This is your how many apples you have at that moment that you're still trying to get. All right. So as the input gear turns, as this turning, these gears, both this output gear and this output gear, they are connected and they're pushed into their gears. Where this hand is the output gear, this hand is going to be the input gear. And as it spins, it's forcing my other hand to do only one thing, which is to push, and it's going to turn it towards me. All right. That's what's going to be happening with it. And in turn, this yoke is going to be moving one way or the other. So as our blue line, our blue arrow, that's coming from our rack. Our yellow, that is going to be the input coming in from this red arrow. All right. This gear here and this gear is coming from the rudder. All right. So as our input is going in, it's the blue arrow. It's inputting a signal. That signal is saying, hey, tilt plate, I need movement in one way or the other. So as this yoke spins, this is physically moving the tilt plate right now. And since now, as soon as the tilt plate starts to move, even just an inch, it may not be fully moved yet, but it starts to move. You start to send hydraulic fluid through. All right. So you don't even have to get that yoke all the way tilted over. You will start to have hydraulic fluid moving through it and being pumped. All right. So we are pumping, 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 pumping. And now since we started pumping, we are getting movement back. Our actual rudder is moving. And since the rudder is moving, we are now coming to our position that we want to be at. And now that we're at the position that we want to be at, we no longer need hydraulic fluid moving, and we don't want to have to hold our actual helm in. If we want to go 10 degrees right rudder, we don't want to have to hold it at 10 degrees or go back to center the entire time. Just like we were saying in class, if you had to make a right turn in your vehicle, you don't turn your wheel all the way over and then, okay, now it's set. Now in order to hold it at that position, I have to go back to 0 position with my steering wheel. All right. It's the same thing on a helm on a ship. You got to hold 10-degree right rudder. You don't want to be holding it. And then when you're holding it, you don't have to go back to 0 to hold that position. So now we're getting an on stroke to port. So we are having flow going through. The rudder comes back to center. And we're good. All right. Keep in mind, every single time this comes back and the rudder comes either back to center or the tilt plate is in the neutral position, we're having a no flow with the tilt plate, and on the rudder comes back to 0, it's in reference to the rudder being on the 0 position. All right. So if the rudder is on the center line, and that center line on the ship, that will be 0. All right. And then every line off of it, we have either a 10 degrees going off, then we have 20 degrees, 30 degrees, and so on and so forth. Oops. All right. And when we talk about the actual tilt plate, this is going to be the neutral position. So with the differential gears, anybody still confused in how it's working? Everybody kind of brought up to speed on it, a better understanding than last week or 2 weeks ago as far as what we were remembering.
Wait, so is that first turn, it's angling the tilt plate is what you're saying?
So
the blue arrow, whatever the blue arrow.
Yes. Yeah. So this is coming in from the rack position.
Okay.
All right. And the yoke itself, this piece right here, this is what everyone talks about as far as the spider legs. You actually have like a piece of bolt coming off of here and it goes off and it goes to a tilt plate.
Oh, okay.
All right.
So that's moving that.
This is giving input. This is the output. This is the output of this system here, but it's the input to the tilt plate. So right. This is what's sending a signal out to the tilt plate.
Okay.
All right.
Yep.
Anybody else? Okay, cool. So what turns the input gears? So we have the rack. Now right here, that's going to represent our differential. Now, this right here and this rack is basically like a gear on its side. Like you take a gear and you're going to split it open. So all along this whole rack is going to look just like a whole bunch of teeth. All right. And right here, this shaft coming out of the diff is just going to have teeth that are going to match as I represent my ability to draw a flower. That's what the side view, if you're going to be looking like if you're going to be coming in on this arrow right here, directly in line with it. That's what the rack looks like. So that is your input. Input number one, that's coming from the helm. That's coming from the rack. Input number two, that's coming in from the rudder position. All right, what you have at that moment. And the output is going to the tilt plate or the tilt box. So what moves the rack? You have the pilot pump. All right. Now, just like our steering gear pumps themselves, this is always going to be spinning. This is always going to be pumping. All right. But this shuttle valve right here has three positions. One of them is just going to keep looping fluid back around. The others are going to give the other two variants that you have, either crossing flow or going in the direct flow pattern. So right now we're having flow and it's just going through the pilot pump and that's all where it's going. All right. Now, as soon as we go to this position, now we're having flow that's going in to the top part of the rack. All right. Whereas this is a piston and the entire time you would have a signal that comes in from the helm and it's going to push either one side or the other of the shuttle valve and you're going to have flow that goes through it. And at the same time, it's going to be sucking it out from the bottom.
Would you say is gonna push the shuttle valve?
You're going to have either we're going to get into the next slide, but it's going to be basically what some sort of electrical signal coming from the helm. All right, the helm is going to be directly controlling the shuttle valve. So as we go in the other position, you can see we have flow that's going to be going across here. And it pushes on this side of the pump and sucks from this side. All right. So that's how we have control over our rack. So now we have the shuttle valve. We have solenoids. So just like we talked about in class, with solenoids you have, it's basically coiled wire with electricity. All right. And they're basically what you're doing is when they're energized, they're either going to be pulling in the solenoid valve or it's going to be pushing out the solenoid valve. All right. So right here, what we have is a solenoid that's energized and it's pulled in the magnet here, which means that this is going to be a normally closed solenoid valve. All right. So when it's de-energized, it's going to fail closed. All right. On either side of here. That's when you're going to hear reference to of normally open or normally closed. All right. Normally open would mean that as soon as it's de-energized, it's going to fail open. All right. And it depends on which systems that's going to be the safer or which side will be. All right. So just like when we talked about with water making, we would want something to fail open when it's going to fail to the bilge, all right? Because we wouldn't want to throw salt water into our distillate tanks. But you would want something to fail closed is the valve that's going to our distillate tanks. So if you lose electricity to the ship and you have flow coming out of your distillate tank, you're going to have no flow going to your distillate. You're going to have no flow going to your distillate tanks because it's going to have a failed closed, a normally closed solenoid valve. And then you have a normally open solenoid valve that's going to be going to the bilge. All right. See how the both are in the safest position, and it just depends on which one you want. So this solenoid here is energized. It pulls in our magnet right here. And now we have flow going through those positions. Now it de-energized, and both sides, this is de-energized and this is de-energized. We are in a no flow condition. It's not going to the rack. All right. This side over here is the rack. And this side over here is the pilot pump. So when this solenoid energizes, it's going to pull in. And now we have a cross flow position. And it de-energizes, and you're just having flow going through the pilot pump. Any questions so far? All right. So when you have your helm, you either have positive voltage or negative voltage, depending on which way it's going to actually be turning. All right. So when you go to port, when you turn to port, you're going to get a positive voltage. The more you turn to port, you're going to get a larger voltage. So when you go to starboard, you now have a negative voltage. All right. And the same thing again. The more you turn, the more of a negative voltage you have. So moving rack to port generates a positive voltage. The larger voltage it is, the more you're going to have rack movement one way or the other. All right. Again, we'll re-hit this when we hit electricity. This piece is not important until we go into electricity. So basically what we have is the helm position and the rack position. Helm to port of the rack. So basically, as soon as you have your helm position is different from the rack position. The helm is to the more towards the port side of the rack. You're going to have a pull that's going to allow it to basically pull the rack more towards the port side to get a stronger pull. And then the same thing for the opposite direction. If the helm is farther starboard to the rack, you're going to have a greater negative pull. So the rack is going to even increase more towards one direction. So as we go through the steering sequence, so the steering gear pump, both of them are running off stroke. So the tilt plate is in a neutral position. The pilot pump is recirculating, so it's constantly flowing. The helm rotates for right rudder. All right, so this is just the helm moving. The starboard solenoid energizes, and the shuttle valve directs pilot pump discharge to the rack position. So now we are starting to actually have movement. All right, the solenoid is energized. We now have flow coming out of the pilot pump and going into the pilot pump's piston that's going to move the rack. So the rack moves to starboard. So turning the differential gear number 1. Remember, this is the input that's going to be coming off of the rack itself. So the rack movement has matched the helm movement. Because remember, how much you turn that helm one way or the other is going to be how much that rack is actually going to move. That's the big thing. It de-energizes. The rack movement matches the helm position. So once it matches, it de-energizes the solenoid and returning the shuttle valve to the neutral position. So the rack still if that's that arrow right there is the neutral position. Just like the rudder, just because we have met what we want to get to doesn't mean that we have to bring the rack back over to the neutral. All right, just because we have reached a point where we want to get to doesn't mean we come back to our neutral position. Just like when you're steering a car, doesn't mean you, after you make your right turn and you're going to make your right turn, you have to bring your steering wheel back to neutral in order to hold that right turn. All right. So this is all of it going in one full sequence. So again, number 1 matches with number 1 right here, even though they're not numbered. So steering gear pump is online, pilot pump online, both actually having flow. All right. The helm moves to starboard. Our shuttle valve gets sucked into its solenoid because the larger increased voltage that we have here is going to have an actual effect on our solenoid. All right. So now we have flow. We have flow coming out of this side and going into this direction. Our rack moves. So our rack has moved to match the position of the helm. Now that it's matched the actual helm position, our shuttle valve now has no differential and it comes to a neutral position. And if you notice, even though it's in the neutral position, we have not moved our rack position. And last but not least, the rack has given an input to the differential. Any questions on what the sequence has been so far before we move forward? Because it's the other half of the sequence we're going to get into in a second.
Wouldn't moving the wheel after they're at equilibrium, like moving it back to the center of the rack, wouldn't that generate another voltage and then like move the rudder again or move the pump? I don't know. So
when you're, so re-ask that again. So if you have to, so if you stop the sequence right now and you take that helm and you move it to another position, is that what you're asking?
Yeah, if you were to move the rack. Yeah.
All right. So if we stopped right here and we were in mid-sequence and we moved our helm, if we went either the port or starboard, either choose a direction, the same thing will happen. It's just which direction it will go. All right. So since we'll stick with the starboard and we're going to continue to move to starboard. Oh, 10 degrees isn't enough. Let's go to 15. All right. All what's going to happen is it's going to restart the sequence. All right.
Okay.
You're going to skip over 1 and 2 because those are always running. All right. We go to 3 because now we need more. Basically, we're going to go to starboard. Instead of 10, we're going to 15. All right. This will remove again. The shuttle valve will move. We'll have more flow. All right. Even though this has reached the peak stroke, basically, it doesn't show and doesn't do it justice. It still has more movement to give.
Okay.
All right. This rack will meet, and it is basically, it will move as far as what you're going to have. All right.
Okay.
So there's markings on it. It will have markings like 0. They'll have a 0 marking, a 5, and they'll have all the little lines in between. It's basically looks like a ruler.
Okay.
All right. So you're still going to have flow. And as soon as it matches 15 degrees, remember, this is going to give an output. And as soon as it has a 15-degree mark is hit, basically, this will go back to the neutral position. Whoops. It's doing it again. All right. This will go back to its neutral position. And now we have a 15-degree mark right there.
Yeah.
All right.
Okay.
Any other questions, or to make sense, or? Okay, cool. So the other side of the steering gear sequence. Remember, all we have done at this point is just give an input. We have only given one input into the differential. We have had no movement to the rudder. We have had no movement so far of the tilt plate, and we've had no movement of hydraulic oil on this side of the sequence. All right. So we have done 7 steps and have not even moved our rudder. So differential gear outputs steering pump on stroke. All right. So that is the yoke right here. This whole entire quick little blurb here is the yoke moving. So the differential gear output puts steering pump on stroke. So that yoke moved. It has moved the tilt plate, and the tilt plate is now causing the pistons to go in and out. All right. That's that entire sentence right there. All of that is happening. The rams driven by steering pump discharge. The rudder begins to move to starboard. The rudder motion transmitted to the differential gear, input number 2. The differential gear output takes steering pump off stroke. The rudder motion stops, and the next helm movement will restart sequence. All right? And in the middle of this sequence, you can restart it basically. If 10 degrees isn't enough, just like we talked about, you can go to 15, and this will just continue the sequence even more. All right? But just keep in mind that when you move to 5 and you move to 10, as soon as you start having rudder movement, this is going to be happening continuously. So remember what spot we were up at the last time with the drawing. We've only given input to the differential. The differential has moved the yoke. The yoke is moving our tilt plate right here. This is our tilt plate. Our tilt plate moves. We now have flow. All right. Now as the rams move and the Rapson slide has actually repositioned. All right. And has repositioned our rudder has officially moved to the position we want it to be in. And keep in mind, in this entire sequence we've said, this helm is still at 10 degrees right rudder. All right. No one has moved it back to neutral. No one has done anything else with it. So we are officially at 10 degrees. 10-degree input is saying, hey, differential, I'm at 10 degrees. You don't have to be moving me anymore. I don't want to move anymore. All right. The yoke comes back to the neutral position, and it causes the tilt plate to come back to neutral position. And now we are still having this pump right here. It's still spinning, but it's not outputting any hydraulic oil. All right. So this rudder here is locked hydraulically. These rams will not move. And again, at 15, if we want to do anything else, it just will restart the entire sequence. All right. So, any questions on steering gear? Anything that we've gone over?
The shuttle valves are closed normally, right?
The shuttle valve. So the shuttle valve has the 3 positions.
Or no, sorry, the solenoids, rather, sorry.
So those solenoids are, and it's all in reference to what is happening when there's no electricity going through it. All right, so they are normally closed position.
All right.
All right,
Nice.
so when no electricity is going through, which way is the magnet? Is the magnet going to be drawn in, or is the magnet going to be pushed away? All right.
Yeah. All right.
Any other questions? It's a nice little review for everybody. Everyone feel better about as far as what we're doing?
Yeah, that was a lot better.
You understand it a lot better. Good. So, let's see. All right. So, right now we're looking at quiz on Wednesday. Make sure you know how to log into Blackboard. All right. I'm going to be posting the quiz up there. It's going to be timed probably like 10 minutes. All right. What else? So, with this going through, like I said, we're going to be doing some sort of final. I'm going to figure it out as we go along. I know what we had. We lost that entire week with review for the final. It stinks, but it is what we have done. That whole week got eaten up by this illness. All right. When is the test? So let's see. Come on. Pull out my work laptop because this stinks and I don't use it. And I'll pull up our rough layout. So we are going to be getting into hydraulics 3 next class. All right. And the other thing we are going to be doing after that is going to be hydraulics. So we got hydraulics 3, and then we're going into electricity. All right. Now with electricity, I just picked up this book, and this book is really good. You pretty much are going to see these almost on every merchant ship you go on to. All right. It was $12 off Amazon. And it's the uglies. Wow. Okay. That's flipped. Where is my settings? Okay, so this is Ugly's reference guide. All right, they're really good. Basically, it breaks down and it's not like it's going to be required, but if you want to know what Ohm's law is, it's broken down really quickly on how that is. The other nice thing is that you're going to use this, as far as what I see, through your time at Maritime. They also have, if you want to get into electricity or plumbing or anything else like that, they have all of those abilities. But what makes it nice, let's find this out quickly. Where is it? Okay, so here's the good thing. Like most electrical books that we have in the industry, this is actually geared towards like operators, which what we're trying to be. All right. So here's a basic motor controller circuit. All right. And we're going to get into the breakdown on that, but to find information on this in any good book is hard to. All right. So I would highly recommend getting these. They're, like I said, it was $12 off Amazon, and almost every single ship you go onto, someone will have some sort of a copy of these out there because they're that good. All right. They're also quite small. I mean, this is my head compared to it. It's not a big textbook. So let's see. Today is the 23rd. Today was actually supposed to be test 3, guys. So we're going to probably need a week for electricity. Probably somewhere on the April 6th or something along those lines. 6, 8, 13, somewhere around there. I'll have to figure it out as I go through with it. Because we're going to need the 25th for hydraulics, the 30th for electricity, the 1st for electricity, the 6th for electricity, probably the 8th, April 8th, depend on. All right. So, any other questions? Nothing is confirmed yet.
Quiz next class is just on steering gear.
So the quiz next class is going to be just steering gear. So we're going to basically have the quizzes that are going to be just on what we learned in the last class. I'm not going to throw something like just random valves into there. Okay. Also, big thing that you guys should look out for when using Zoom, just not in this class, but other classes. Some people allow you to, like, I believe I have it set so that way you guys can talk to each other if you have questions or like, what did he say mentality. So just make sure if you're going to be talking to each other like that, there is the option to click everyone by accident. All right. So just be aware of that. So, all right. Any other questions? Everyone pretty good? All right. I will be posting my office hours. They're probably going to end up being almost all day Tuesday, all day Thursday. All right. Same thing goes as when we are having class. If they don't work, email me. I'm not going anywhere. I'll probably be around to do it. All right. We're all locked and confined to our homes. So that's really it. If you guys have any questions, you could stick around into the end of the, basically, I have another class at 11:30, the other 5:40 class. So if you have any questions, I'll keep this meeting open until then if you want to ask. All right. Other than that, I'll see you guys Wednesday.
Just from logging in, you have our attendance, right, and everything?
Yeah, just from you logging in, I have your attendance.
Professor,
what's going on?
So I missed test 2 because I was out sick, and
yes.
We're going to figure it out after classes resume.
Okay, so yeah, so you gave me a chit. So is Finn in here? Did he leave? Yes. Okay, so we will take care of that. I know you have a chit, so we'll figure out what we're going to be doing for that. All right. Probably do it sometime this week. All right, maybe Thursday or maybe next Tuesday. All right, just so you can get you up to going. All right. Email me with after you kind of meet with your teachers, if any, and tell me your schedule that will fit best. All right.
Okay, and we would do it on Zoom.
Yeah, basically.
Okay.
All right. So just let me know when you have time this week. Try it like Thursday. If that doesn't work, we'll do like next Monday or Tuesday.
All right. So tomorrow I'm gonna meet with all my teachers. So after tomorrow, I'll email you with the plan and everything.
Okay. All right.
All right. Sounds great. Thanks so much.
Have a good one. Who else has questions?
So I'm still a little confused on the differential.
Okay. Is everybody else the differential too? All right.
Chloe, you got to unmute yourself if you want to talk.
I said, yeah, pretty much.
Okay.
I just don't want to go to dynamics, but I'll watch anyways.
Where is the PowerPoint? There it is.
Have a nice day, folks.
Have a good one.
Turn 7. Let's get something to hold.
Okay. I'm not going to bring that up. So as we go through, and I still try and figure this out. So I can see you guys. Share screen. There we go. We have both of our input gears. All right. Now they're both coming in and they're giving a signal. So input gear number 1 is what you want to have. All right. Input gear number 2 is what you have at that moment. That's coming in from our rudder. Now our output gear is going to, and it's going to be basically spinning the yoke in one way or the other. All right. Now let me swap. All right. So your yoke is going to be going in one direction and it can go the other direction. All right. So these output gears will spin because of these input gears. All right. And like I said in class, where if you put your hands like this and you try and move your input gear, your left hand, or if your right hand, if you're doing this, it's going to force your hand to spin. All right. And now since they're attached to the yoke, they can't just free spin on here. So they need to move in order to get more gears, because each gear teeth is going to be putting a force on it. And that force is being applied, and it's going to basically, it has to have movement. It has to escape somewhere. And that escape is going to be going, and it's going to be propelled by this yoke. It's going to be outputted that way. All right. Does that explain it better, or is it still confusing?
So when input gear 1 is turning, is input gear 2 stationary?
Yes and no. For the most part, yes. All right. So remember, like we were talking about at any point in the sequence, if you could take your steering wheel and you take your helm and you move it more, you go, oh, that wasn't enough, I got to go more, and you go again, it will restart the whole sequence. All right. So this gear right here may be in the middle of moving when you're going to have a new signal coming in from your rack. And it'll just turn it more. Okay? Or it will just keep it in that position for longer. Because remember, that tilt plate isn't just going to keep tilting, and then all of a sudden flip around. All right? So it may just hold it in that position for a longer period. All right? But that still means is that, for the most part, we're going to have this input having, it's just that whole aspect of the apples in the cart. All right? You may all of a sudden be having 10 apples that you need for your recipe. And then whoever you're shopping with comes up to you and said, no, it's not 10, it's 15. And then you're just going to have to revamp for it. So now you're thinking 15, and your want and what you have and what your output is just going to change to that variable. All right. For the most part, this is stationary, but it will move because it's still going to have input coming in from the rudder. As soon as you start moving this input gear, as soon as you move it, your yoke is going to move. And your yoke moves, now your tilt plate is moving. Now you're sending hydraulic oil to your rams. Now your rams have moved, it has moved your rudder, and now you're having input coming back out from the rudder and going into your differential, and it's moving this. It's all happening simultaneously as it's going through. All right? Better? Worse?
Yeah, thank you. That's
Okay.
much better.
Anything else about it, or?
Nope.
Okay.
That is it.
Good.
So if you want to have like, let's say 5 more degrees, then input gear number 2 would like reset, and then the whole process will go again.
So basically, if we look at the next slide here. All right. Input gear number 1 is the blue. All right. That's coming from our helm. Now, if you look there, we are now off stroke. And input gear number 2 is the yellow, and it's coming from our rudder. Right here is our rudder. All right. If you notice, the arrows were pointing up, and at the end, now they're pointing down. But it's still having a neutral flow. We're having no flow. It's the tilt plate is in a neutral position, but our actual rudder is not in a 0 position. All right. So if you were to have, like you said, another 5 degrees, if you needed 5 more degrees, you would basically, the rack would move. The rack would move input gear number 1, which would move the yoke. And from there, you would start to have flow again. And then input gear number 2 will have and correct for it. So it's going to have basically, it's going to come back in, and it's going to try and put it back to the 0 position, back to the neutral position. Okay?
Okay, yeah, that makes more sense.
Okay. Any other questions? It doesn't just have to be on this. Or it can.
Nope, I think I'm good. Thank you.
Yep.
Yeah, I'm good too. Thank
All
you.
right. I will see you guys on Wednesday. If you have any problems, let me know. All right?
Will do, Professor.
Have a good one, guys.
Thanks, you too.